This video is going to cover Section 1.5, targets 1.7 and 1.8, the same targets from Section 1.4. Slope and parallel lines. Two lines are parallel if they have the same slope. So for example, it says write an equation of the line passing through the point -3, 1 and is parallel to the line y equals 2x plus 1. Well, we know that if it's parallel, if another line is parallel to this, it's going to have a slope of 2, and then going through the point -3, 1, since we have the slope and we know a point, we are going to use point slope form. So this is where you do y minus the y minus 1, the y that you're given, equals 2 times x minus the x value that you're given, or -3. So when we simplify that, we get y minus 1 equals 2 times x plus 3. This is point slope form. And then if I asked you to rearrange it into y equals, you want to distribute the 2. So you get y minus 1 equals 2x plus 6. And then just add the 1 to the other side. And you get y equals 2x plus 7. And now the equation is in slope-intercept form. And you can see that the line that we had at the beginning, 2x plus 1, is parallel to the line 2x plus 7. Same slope, but different y-intercepts. Slope and perpendicular lines. One line is perpendicular to another line if its slope is the negative reciprocal of the other line. For instance, if you have a slope of 5 and a slope of -1/5, those two lines are perpendicular because they multiply to a -1. A slope of -2/3 and a slope of 3/2, these are negative reciprocals, and so therefore the lines would be perpendicular because the slopes multiply to -1. So that's what a negative reciprocal is. The number has been flipped, and then you take the opposite sign. Example, find the slope of any line that is perpendicular to the line whose equation is x plus 4y minus 8 equals 0. Now the line that's given is in general form, so the first thing we need to do is figure out what the slope of this line is, and I'm going to do that by getting it into slope-intercept form. So I add the 8 and minus x from both sides to get 4y equals -x plus 8, and then divide everything by 4. So 4y divided by 4 would give me y. -1 divided by 4 will give me -1/4, and 8 divided by 4 will give me 2. So this equation is the same, represents the same line, but is a different equation. We started with general form, we converted it to slope-intercept form because in order to find the slope of a line that's perpendicular, we need to know the slope of it. And general form doesn't tell you what the slope is. So the slope of the line given is -1/4, so the slope of the perpendicular line would be its negative reciprocal. So flip 1/4 to become 4, and then make it a positive. So the line that is perpendicular to that will have a slope of +4, since -1/4 and 4 are negative reciprocals. Another example, it says write the equation of the line passing through the point 3, -5 and is perpendicular to the line whose equation is x plus 4y minus 8 equals 0. And then it says express the equation in general form. Well, this is the same equation that was in the last example, so we know this slope is -1/4, and so then we know that the slope of the perpendicular line would be a +4. When you know the slope and you know the point that the line goes through, we want to use point slope form to begin with. So we're going to start out with y minus our -5 equals 4, that was the slope of the perpendicular line, times x minus 3, our x value that's given. And since it says to express it in general form, that means we want to get everything to one side, just like the equation that's given. Everything is on one side. So we're going to simplify this, so we get y plus 5 equals, and then distribute the 4, so 4x minus 12, and then just simply move everything over to the other side. So we'll subtract 4x, and then we'll add 12, and so then we get -4x plus y plus 17 equals 0. The average rate of change of a function. So this is target 1.8. It says if the graph of a function is not a straight line, the average rate of change between any 2 points is the slope containing those 2 points. And this line is called the secant line. Average rate of change is similar to slope. I'll show you an example. It says at age 13, a boy is 57 inches tall, and at age 18, he is 76 inches tall. What is the boy's average growth rate? Now we know that you guys don't grow at a linear rate. You always grow different. There's a little spike when you're younger, and then you kind of grow at a more steady pace, and then you have another spike during adolescence. So if you look at the blue graph, it's not linear, but we still want to figure out what the boy's average rate of growth is. And so what we're going to do is find the slope of the secant line. A secant line is a line that connects 2 points on a curved graph. So we want to find the slope between 1357 and 1876. So we're going to use our slope formula, the change in the y's over the change in the x's. And when we do that, we will find the boy's average growth rate. So first of all, our y2 minus y1 is 76 minus 57. Our x2 minus x1 is his years, 18 minus 13. We get 19 over 5, and we get that to be 3.8 inches per year. So even though he grows at a different rate each year, on average he's growing 3.8 inches a year. So you can find the average rate of change between 2 points on a curved function. You just draw a secant line between those 2 points and then make your slope triangles. Find the rise over the run. Another example is this graph that I have here. This is just a cubic function. And remember, the average rate of change is the slope of the secant line. So go ahead and sketch this graph onto your notes, and then make sure you have the points 2, 1, and 3, 4 in it. And so we want to find the average rate of change between 2, 1, and 3, 4. I know this is a curved function, so technically it doesn't have a slope. So what we want to do is draw a secant line between these 2 points. So here's my secant line, and then find the slope of that line using your change in the y's over the change in the x's. So 4 minus 1 is going to be my change in y's. 3 minus 2 is my change in x's. Therefore, my slope is 3 over 1, or just 3. So the average rate of change of this cubic function between an x value of 2 and an x value of 3 is a slope of 3, the average rate of change. And lastly, if you're not given the graph, but you're given the equation, we want to find the average rate of change of f of x equals x squared. Now x squared we know is a parabola, so it is curved, and we want to find the average rate of change first between x equals 0 and x equals 1. Well, in order to find the slope of the secant line, we also need the y values. So plug 0 in for x into the equation and get the y values. And when you do that, you get f of 0 equals 0 and f of 1 equals 1. So then next we want to find the change in the y's over the change in the x's. Well, this part right here on the right, if I do 1 minus 0, is the change in my y's. And then the 1 and the 0, my x's, I'm going to find that difference as well. Put the rise over the run, we get 1 minus 0 over 1 minus 0, which is just 1 over 1, which simplifies to just a value of 1. So the slope of the secant line, or the rate of change between 0 and 1 on the parabola x squared, is 1. Let's try another one. X equals 1 to x equals 2. Let's find the average rate of change between these two x values. So first we need to plug our x values into the formula to get our y values. Then we're going to find the change in our y's. Put that over the change in our x's. So then we get 4 minus 1 over 2 minus 1 equals 3 over 1, which simplifies to 3. So let me show you on a graph real quick what we just found. So in letter A, we wanted the rate of change between 0 and 1. So we know that the parabola is curved. We have to draw a secant line and then find the slope of that. And the slope of this red dotted line is just 1. The next part said to find the rate of change between an x value of 1 and an x value of 2. So I'm going to draw a secant line between these 2 points and find the slope of it. If I counted over 1 and up 3, I would get a slope of 3, which is what we calculated on the previous slide. And then our last example, oops, wrong way. Our last example is finding the rate of change between x equals negative 2 and x equals 0. So I'm going to do the same thing, plug in my negative 2 into the equation, plug in 0 into the equation to get your y values. So we get f of negative 2 is 4 and f of 0 is 0. Then we find our change in our y values, so 0 minus 4. And then we're going to put that over the change in our x values, 0 minus a negative 2. So 0 minus 4 gives us a negative 4. 0 minus a negative 2 gives us a positive 2. When we simplify that down, we get a slope of negative 2. And on the graph, it's going to look like this. My secant line is now going to be between 0 and -2. It'll let me click on it. There we go. So the rise is 4, and the run was a -2, and therefore we have a negative slope of that green line. That's the secant line between 0 and -2. The slope is -2. And this was the video that covered Section 1.5, targets 1.7 and 1.8.